Yo, what's going on, guys? REAPOFF here, and welcome back to another video. Today, guys, it's really exciting because I'm going to announce the development of a new program I'm working on called Skork. And this program is completely open sourced. Before we get into actually what the program is as of now, I'm going to talk about that it's open sourced, and why that's so important is because, well, I'm trying to make this transition in my channel where I'm doing more programming and math type of videos and stuff like that. And what better way to make a open source project so that I don't have to conceal code to anyone. Anyone can see it because the entire source code is on GitHub. And if you follow this link, which is in the description, you can literally clone this repository, right? And then you can work on it. Let's say you want to make a change or you want to add something. And you could commit that change, and then I can see that change. And if I like that change, if it's actually a change that is actually in the direction of the program, well, we can commit that to the actual project. Or to the branch, the master branch, the one that I'm working on. And so yeah, that's really, really cool. And well, that transitions us to what the actuals, what is Skork? What is this weird name that I give to programs? I'm kind of known for that, giving ambiguous names to programs. But anyways, Skork is a custom compiler for a custom script-like language for a sort of game. So this description isn't really justified in that it's not really, I don't have a set goal in mind. It's ambiguous. There's like here and sort of a game, basically. So it's not really clear as to what I'm doing, and the reason for that is I actually specify that here. It's a prototype that I have right now that is likely to be very different with each change I commit to the repository. And it's not really a great way to introduce this program, but I won't lie. I'm kind of recording this, preemptively before actually thinking about this stuff. And yeah, I'm going to show you what I mean by this language here in a visual way of what this game or what this program is programming, right? Or whatever you're doing. So to break it down further, we're going to take a look at this grid. Now, we're going to zoom into it so our eyes don't hate us, really, for looking at this. So we have boundaries. This is the output screen. And actually, before we get into that, let me actually just show you the GUI as of now. This is the GUI. We have the code window and the output window. Let's expand that. Let's open this up all the way. Okay. And now we're going to zoom into it. Just have to get in this control, zooming with the mouse, or you can click down here and zoom in however you want. But I want 500% so we can see everything. So we have a code window here. We type code in, and then something happens out here. Now, what type of code are we typing in? Well, if we go back, it says is a custom compiler. So basically, it's going to take whatever you type in here and compile it to C# code. Okay, and C# compiles to assembly. So it's kind of a nested compilation. This is not a very efficient thing to do in programming. For example, Java is a programming language in which something called the JVM, the Java Virtual Machine, is constantly running to compile Java code into bytecode. And a good way to think about this is like how C or C++ compiles code into assembly, and there's a similar relationship there. Basically, to preface that, if you're trying to make something extremely efficient in Skork, like writing a program that's supposed to do something really efficient, it's not, because of that problem right there. It's just the nature of how this program is. I'm using C# to make a language, basically. So it's going to be a programming language, but it's going to be very, very dumbed down programming language. It's going to use a lot of commands that are already built into the language. Like for example, left. What left is going to do is going to move some sprite on this screen 1 unit to the left, or if I specify a number, it'll move it 6 units to the left. Or if I put an I here, well, I'd have to define I. So int I equals 10. And now it's going to move 10 units to the left. And what does that look like? Well, let's take a look at Photoshop here. I have a boundary here. This is the boundary. So if I move left, this is the sprite, the black dot. If I move left or up any amount, it will halt. It won't run the code and it will just stay where it is and it'll halt. So we've reached a halt state in the program. Now, if I do that very same command where I do left 1, I'm going to move this black dot from there to here. So let's just see what that looks like that. And then vice versa, we can go from here to here. So that's kind of how it's working. It's very simple. It doesn't use anything more complex than that, really, for the moving functions. And now there's other syntax, which, by the way, no syntax has yet been programmed. But I want to really show you guys a initial detail of how this program will look like in the future, hopefully. So yeah, we have syntax, so we need to follow. For example, a loop in Skork will look like this, from X to Y. Now, if you ever taken a C class, you'll know that this is a structure pointer. This symbol is a structure pointer. And in Skork, it's going to represent a loop from this to this. I could have done this. I could have done that, possibly. But I'm choosing this because it's a custom script-like language. I'm defining the rules of this language as we go. Now, for example, you'll have stuff in here. You know, go left 1 unit. So I don't even have to put anything there. The default is 1 unit. If I put in 5, we're moving 5 units for every iteration of this loop. Now the way I'm going to build actually these structures, for example, left 5, this is a recursive definition of the left function. And the same thing will be for up. Up 10 is a recursive definition of just the up function. And you apply that recursion n times, or whatever the argument is in here. Now this program is working on integers. So any whole number, no decimal points, so this doesn't work. It's just going to give you a syntax error. So you gotta be careful, you know, stuff like that. As of right now, I might truncate it to an integer. There might be clever things I do, but as of now, I want to try to keep it as simple as possible. And what is the point? Why would I do anything like this? It doesn't make any sense, right? So what is the purpose of Skork? Well, Skork is essentially a game in which you program. You will define rules for the game, and you can specify how those rules change within the program as it runs. Those two things coupled give Skork a way to create a game that you define dynamically. For example, in this grid, we have a red square, which is a sprite, and we can apply various functions to it, like the left function I mentioned before. There is a game called Conway's Game of Life. In this game, there are very simple rules. Think of each square as a cell, and either it's occupied or not occupied. Where the space is filled in, you can think of a 1, and where it's not filled in, you can think of zeros. So you apply the rules to this starting configuration, and you can get very simple, not interesting things happening, and very complex things happening. This game is captured in about 4 rules, though. In Skork, you can define as many rules as you want and change them dynamically. So that's where it comes into. You can create your own game of life with your own rules, or you can create something completely different. I'm only using Conway's Game of Life to kind of demonstrate a working example of what Skork might be able to do, but it goes much further than that. You are defining the rules of this game. okay? And no matter what you do, this process will run. So for example, like looping from X to Y, right? And I want it to, I just have these rules in here, right? These are rules. And then I can reconstruct Conway's Game of Life in Skork, if possible. If you know the right code, you can construct it. This is ideal. But the idea is that you're constructing your own game every time. You're not limited to this is the rules. You create the rules. And you can go beyond to maybe edit the rules itself dynamically. So for example, if I find a configuration that looks like this exactly, I can edit all of these rules that I've already defined before, and then it creates something completely different. You know what I'm saying? Like, you can completely have control over this program, but you have to follow very basic syntax and very limited syntax to do it. So instead of programming it yourself, you follow this program. And so that's the whole idea of Skork, guys. It's a weird name for a game or a pseudo-programming language for a type of game that has infinite possibilities. So with that being said, guys, I hope this is a good place to stop it here. If you did enjoy the video, please leave a comment what you guys think. And I will definitely be working on this application, because I will have a lot of programming to do this summer. I have quite a bit of activities I want to achieve this summer. And this is one of my fun projects, so this is going to be something I develop for video content and stuff like that. So thanks so much for watching, and peace out now.